One of the questions a lot of people missed on our pre-assessment was an equation involving radicals. So I wanted to look at how you can solve equations with radicals. It's really very simple, and it follows most of the things that you know about equation solving in the first place. What you're really trying to do here is you want to isolate the radical, because I would like to be able to get rid of that radical. So the first thing I can do here, if I've got anything added, multiplied, that sort of thing, I need to strip all that away from the radical. So remember that when you're solving an equation, you're really moving backwards through the order of operations. So you're really going to take care of addition or subtraction first, as long as it's not inside parentheses. So I'm going to subtract 5 from both sides, and I've got 3 times radical 2x plus 7 is equal to just 15 now. Okay. The radical is being multiplied by 3, so I want to undo that. I want to divide by 3. Be careful about trying to distribute. In general, you don't want to change what's under the radical. There are special cases where you can kind of bend some rules and use some radical properties, but usually they're not going to be real necessary for solving equations. So this is being multiplied by 3. I want to divide it by 3. And so what we're going to end up with here is we're going to get radical 2x plus 7 is equal to 5, okay? If you think about it, the opposite of taking a square root is squaring. So I've got 2 equal things here. I should be able to square both sides of the equation. And if I square both sides of the equation, squaring a radical will get rid of the radical. It'll leave me with 2x plus 7. Squaring it on the other side, of course, whoops, sorry, need to square both sides. Said it, didn't write it. Will give me 25, and then I can subtract 7 from both sides. I get 2x is equal to 18, and of course in that case, x is going to equal 9. So squaring is the opposite of taking a square root. You can basically peel away the layers, get to that square root, and then square both sides of the equation, okay? But make sure you don't do any squaring, at least until you take care of addition or subtraction. Okay? If I try to square this whole thing, it's going to create a FOIL problem, and it would get really ugly, and it's going to make it much worse. But if you can isolate the radical, then you can square it, and you can eliminate that radical. So that's what's going on there. Okay? Let's say that you had something with a cube root. Okay? Let's see, I've got one here. How about a cube root of 4x minus 2 plus 6 is equal to 10? Okay? Same kind of thing. Get the radical by itself, okay? I need to isolate the cube root. I'm going to subtract 6 from both sides. I still have a cube root. Still a 4x minus 200. Now it's going to equal 4, okay? The reverse of taking the cube root is to cube. So I'm going to cube this side of the equation. I'll cube this side of the equation. And if I cube a cube root, it's going to leave me with just what's under the root. 4x minus 2 is going to be equal to 64. Okay, now I can add 2 to both parts here. We're going to get 4x is equal to 66. And let's see, 4 times 16 is 64. So it looks like x is going to be 16 and a half, I think. And that's my final answer. Okay, so be on the lookout for that. Isolate a radical, then square it. Should get rid of everything, and basically allow you to solve the equation at that point.